morning class. So today's topic is based on the first module related topic, that is your anion and cation analysis, which is the first module topic of your course of organometallic chemistry. Now, when we talk of cation and anion analysis, there are certain prerequisites what every student is expected to have before going for this course. First is the student should be able to make initial observation of the physical properties of the salt. Now, what do you mean by the physical properties of the salt? That is, if a salt is given to you, what is the color of the salt? If there is any smell coming out of the salt, and what are its physical properties, right? Whether it is a hygroscopic salt or it is a normal dry salt, these all things comes under the physical properties. Second is study of action of heat on the salt. That is also named as flame test. Now, this particular test is more helpful when you will be reading the PPT or the presentation based on cation analysis, because flame test mainly helps in cation analysis rather than in anion analysis. But initially, whenever a salt is given to you in theory or in a practical class also, because this topic is also there in your practical class, what you're supposed to do is first you have to note down three physical properties: color of the salt, smell of the salt, and the type of the salt. Second is you have to take the salt in a spatula, you have to heat it over a burner in your lab, and you have to see what type of flame is coming in. That also gives an indication of the type of the anion or cation which is present in the salt. Third point is again related to that. Why we are specifically saying is color and physical properties of the salt is because many cations or anions impart similar type of color to the salt. So the student should be able to distinguish between those type of salts as well. Fourth is always a student should be able to make the initial observation and the indication of the type of the anion is present. Now, what is meant by the fourth point is, suppose you are smelling the salt. If there is no odor or no smell coming out of the salt, there is a certain category of anions which we will see which come under that category. So you can say, okay, this particular salt will be having this type of anions. Suppose some rotten egg smell is coming out. That means your brain should work that in the salt you might be having some sulfur containing anion. Suppose some ammonia smell is coming out, then you have to understand, okay, that means some nitrogen containing anion must be present in the soil. So these are the prerequisites that students should know before they are going for this type of analysis. Most importantly, before I start explaining this slide, you should know that these type of analysis are called as qualitative analysis. Why these are qualitative analysis? Because in this, you are not finding out the quantity or amount of anything. You are just identifying the type of anion and the cation which is present in the salt. So, these are called as qualitative analysis. Now, this whole set of anion and cation analysis is based on the fact that whenever a salt is subjected to any type of heat or you are adding any type of acid, there are ions which are present in the salt. There could be cations, there could be anions, right? So, the salt can only give any type of test that we will be doing in this or we will be observing in this only if it is in the cationic or in the ionic form. So, metals obviously in the salt tend to form the cationic part and the non-metals tend to form the anionic part. One more thing, cations are also known as basic radicals. Anions are known as acidic radicals. This you should not forget, right? Now, this whole anion and cation analysis is based on the fact that because the salt can form ions, they are easily soluble in your solvent, and therefore in that you can form the extract. Either that could be a water extract in which salt can easily dissolve in water, or that could be a soda extract in which you will be dissolving the salt with excess of sodium carbonate and you will be carrying out the test. So for this it is very important that your salt is soluble, and it is only possible because there are ions which are present in the salt. Okay. Now, if they have also mentioned that in cations, we have large variety of cations as we know, but the common ones are sodium, potassium, calcium, barium, iron in +3 state, copper in +2 state, nickel 2 plus, and tin that is also in +2 state. These are the common cations found in the laboratory soils. Next is solubility rules. Now, why it is important is that because solubility rule and solubility product plays a very important role when we call or when we consider the formation of precipitate in a solution. So generally the nitrates, chlorates and acetates of the metals are soluble except one of the acetate, that is silver acetate, which is not soluble in water. Second, sodium, potassium and ammonium salts are mostly soluble in water. So you can also perform all types of preliminary and confirmatory tests using water extract. Chlorides, bromides, iodide are soluble except silver and lead and mercury halides. Fourth point, when we talk of sulfate type of anions, all sulfates are soluble except barium, calcium, strontium, lead and mercury sulfate. Fifth, carbonates, phosphate, borates, sulfides, chromates and arsenates of sodium, potassium and ammonium are soluble. Only these are soluble. Apart from that, these anions of any other cation apart from sodium, potassium and ammonium are not soluble. Sixth point, sulfides of barium, calcium, magnesium, sodium, potassium and ammonium are soluble, whereas other sulfides are insoluble in water. Now, I have talked of flame test in the second slide, right? And I have already mentioned that flame test is more important for cation preliminary analysis than your anion analysis. Why this is informed is, or why this is performed is because this preliminary test is also very important for the identification. Suppose if you are heating the salt and if it gives yellow or orange colored flame, then you have to infer for that sodium plus cation may be present in the salt. If it gives a lilac flame or a light purple type of a flame, then you have to infer from that K plus ion may be present. If there is no color, then either magnesium could be present in the salt or ammonium could be present in the salt or aluminium in +3 stage could be present in the salt. If the flame is red brick color, then calcium is present in the salt. If it is green colored flame, then barium would be present in the salt. If the flame is blue-green colored, then copper in +2 state will be present. And if it is a very light blue colored flame, then lead 2 plus salt must be there in the mixture. Now, moving on to the anions. These two slides are stating that the most common type of anions and what are their reactions. First, we are considering the carbonate anion. What is the speciality of carbonate anion is, whenever in a salt where carbonate anion is present, you are adding an acid, a colorless or odorless gas will be evolved. And whenever that gas is passed through lime water, now what is the formula of lime water? It is CaOH whole twice, calcium hydroxide. Then there will be a slight turbidity or milkiness that confirms that carbon dioxide is present. So acid is reacting with carbonate to liberate the carbon dioxide gas. So this lime water test you have to perform because you cannot get an indication of your carbonate anion because the gas getting liberated from it is odorless gas. Next common type of anion is sulphate. Now whenever a salt is dissolved in water and that salt is containing the sulphate, in that water extract whenever there is an addition of barium chloride, then there will be a white PPT of barium sulfate which will be formed. That is why, because barium will, from the barium chloride, will combine with sulfate and will form barium sulfate PPT, right? Next is sulphite. Now you should not forget sulfate is SO4 2 minus, sulphite is SO3 2 minus. Now whenever there is addition of barium chloride is there, and if in your salt sulphite is there, then the barium from the barium chloride will combine with sulphite to form your barium sulphide, which is white colored PPT. On addition of any acid, mostly the sulfuric acid and hydrochloric acid in diluted state are added. What happens is this barium sulfide breaks down and it causes the evolution of your SO2 gas that has a very pungent smell. And one more thing is needed is that whenever you are dipping your or bringing your litmus paper near to this gas, this will convert blue litmus to red. Why? Because SO2 and H2 combines to form sulfuric acid or sulfurous acid. Either that will be H2SO3 or that will be H2SO4, right? Next category is S2 minus. What happens? This is known as sulphide. Now by reacting this anion with an acid, what happens? A very pungent smelling gas. It is more pungent and more strong gas, smelling gas than SO2, that is H2S. H2S gas gets liberated. Next comes the chloride, and now whether I talk of chloride, whether I talk of bromide, and next we will see of iodide, the common test is Agm3 test. Whenever to the water solution of a salt containing chloride, the AgNO3 is added, then the white PPT of AgCl will be formed. And when in this AgCl you are adding any type of acid, you will see the liberation of that acid. Similarly, bromide is present if we are adding AgNO3 to that. So now silver in +1 state will combine with bromide to form the pale yellow colored PPT of AgBl. Right? Similarly, the on bromide decomposition also, the H plus which is getting liberated from it, that also can equally combine with Br minus to form HBr. Similarly, I minus, when AgNO3 is added to a salt containing iodide, then Ag and iodide will combine to form AgI, which is having the yellow colored PPT, and there are, just like other halides, there are chances that H plus might combine with I minus to form Hi, and there is the liberation of white fumes. Next, most important category is of nitrate. What happens in nitrate is this undergoes Brown-Rin test. That is, whenever there is a salt containing nitrate and you are dissolving it in water, now if to that you are adding any concentrated acid and iron 2 sulfate, you will see at the mouth of the test tube there is the formation of your brown colored ring. That confirms your NO3 minus presence. So now Vidya Pitam, and in this we will see the different types of preliminary and the confirmatory test of the carbonate anion. First of all, carbonate anion is an inorganic salt quantity. In this, there are 3 oxygen atoms which are attached to the carbon atom, and the shape of carbonate is actually trigonal planar, and it is mostly found in salts and in rocks in the form of calcite. How it is done is, the most common one is for the test of carbonate, whether it is preliminary test, and we will also see in confirmatory test the water extract is taken. So the different types of preliminary tests are physical examination first, second dry heating test, third is dilute sulfuric acid test. Let us first see how a physical examination is being carried out. First of all, always the carbonate containing inorganic salts are white in their physical appearance and they are odorless. Next is dry heating test. What are the materials that are required? We need the original salt, we need test tube, we need lime water, that is calcium hydroxide solution, we need test tube holder and Bunsen burner. How it is done is, first in the test tube we take the solid salt, we heat it over the burner. Now on heating, what happens is the carbonate anion which is present in the inorganic salt decomposes to release out the carbon dioxide gas. Now that carbon dioxide gas is being collected in a test tube, to which, that is the test tube in which the gas has been collected, the lime water, that is calcium hydroxide solution, is added, and as you can see in the reaction, it turns milky because of the formation of the calcium carbonate in the test tube. Next is the dilute sulfuric acid test. What are the materials that are required? We need the original salt, we need lime water, we need dilute sulfuric acid. In the test tube, how it is done in the procedure? In the test tube, first of all, we take the solid salt, then to that we add dilute sulfuric acid. Now what does the acid do is, acid is decomposing the carbonate anion so that the carbon dioxide gas is liberated, as you can see, and it is visible in the form of very light effervescence in the test tube. To that,
first of all, we put another tube so as to collect the gas, as we have done in the previous preliminary test. Then to that gas again we will add the lime water, so that the lime water turns milky because of the presence of carbon dioxide. And what is this milkiness? It is your calcium carbonate. Now let us see the different types of confirmatory tests for carbonate. They are dilute hydrochloric acid test, magnesium sulfate test. So first, what is being done in the dilute hydrochloric acid test? The materials that are required are test tube is needed, in which your salt solution is there, dilute hydrochloric acid, lime water, dropper, test tube. What is the procedure? We take the test tube. To that, we add the aqueous solution of the carbonate containing salt. To that, we are adding dilute hydrochloric acid. See the formation of brisk effervescence, as you can see. Now, why this is coming out? This is due to the evolution of the carbon dioxide gas. See, this is your carbon dioxide gas. Again, we will collect the gas properly in another test tube. Once this whole of the gas have been transferred to a test tube, we will cover it, and then slowly we will add calcium hydroxide. This white PPT is due to the formation of the milkiness, which is due to the formation of the chemical component of calcium carbonate. Now, this is one of the confirmatory tests. Second confirmatory test is magnesium sulfate test. What are the materials that are required? We need the salt solution. We need magnesium sulfate solution, test tube, dropper. Now, what is the procedure of this? We take the test tube. To that, we add the water solution. Then we dropwise add the magnesium sulfate solution to the test tube. Formation of this dark white PPT due to the formation of magnesium carbonate again confirms the presence of carbonate anion. What are the precautions to be taken? First of all the apparatus and the chemicals required should be handled properly. To collect the gas completely, always the test tube should be covered properly in which you are collecting the gas. Always for transferring of any reagents, we should use droppers, and while performing any chemical test, we should wear proper gloves. So this is how a test of carbonate is being done.
So these are some of the very good books which you are supposed to refer for this, and these are some of the online sources.